next is I will give you an idea about the common engineering curves used in the drawing. First of all, the first curves are conic sections, and the conic sections are ellipse, parabola, hyperbola, and these are called conic sections because these curves appear on the surface of a cone when it is cut by some typical cutting planes. So this is a cone, and this cone is cut by a section plane. So this is cut by a plane, and this section plane cuts through the generators, and you will get and remove the apex portion. You will get the shape called ellipse. So this is the ellipse. Again, the cone is cut by a section plane which is parallel to the end generator. The section you will obtain is a parabola. This is parabola. And the third one is the section plane parallel to the axis. You will get the curve hyperbola. And the common definition of ellipse, parabola and hyperbola are: these are the loci of points moving in a plane such that the ratio of its distances from a fixed point and a fixed line is always remains a constant, and that ratio is called eccentricity. So in the case of ellipse, the eccentricity value is less than 1. If it is a parabola, the eccentricity is equal to 1, and if it is a hyperbola, the eccentricity value is greater than 1. And the another definition of ellipse is: it is the locus of a point moving in a plane such that the sum of its distances from two fixed points always remains a constant, and the two fixed points are called focus, and this sum equals to the length of the major axis, and the two fixed points are the two focuses, the two foci, focus 1 and focus 2. The first problem is: draw an ellipse by using concentric circle method. This method is also known as auxiliary circles method, and the data is given as the major axis as 100 millimeter and the minor axis as 70 millimeter long. So first of all, draw two lines AB and CD, and AB is the major axis which is 100 millimeter, and CD is minor axis which is 70 millimeter long, and with center O and diameter as major axis and minor axis, draw two circles as shown in the figure, and divide the 360 degree of the circle into 12 equal parts. Mark the bigger circle as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as shown in the figure, and the smaller circle as 1, 2, 3, etc. as shown in the figure. So draw a perpendicular line through point 1, 2, 4, 5, you can see 10, 9, 7, 6 as shown in the figure, and draw parallel lines to major axis through 1. It will meet similarly parallel lines from all other points as shown in the figure. You can see you will get the point. So this is points, these are the common points blinked, these are the points, you can see the points. So you will get all the points and draw a smooth curve passing through all these points. So you will be getting the ellipse. And the second question is: draw an ellipse by rectangular method. So this method is also called oblong method, and the dimensions given as major axis is 100 millimeter and the minor axis is 70 millimeter. So divide the major axis AB 100 millimeter and the minor axis CD 70 millimeter, and construct a rectangle, and the length of the rectangle is major axis and breadth of the rectangle is minor axis, and divide the left end into 3 equal parts as shown 4 equal parts as shown in the figure, and divide the the left of the line AB into 4 equal parts as shown in the figure, and mark it as 1, 2, 3, and join D1, D2, D3 and join C1 and extend it to the line. It will meet the line D1. Similarly, join C2 and extend it and it will meet the line D2. Similarly, join C3 and it will meet and extend it, it will meet the line D3. So, and mark the points. You can see 1/4 of the ellipse. So this is the 1/4 of the ellipse, and you can transfer the points on the right side and bottom side, and you will get the ellipse. So this method is called draw an ellipse by rectangular method. Next is the draw an ellipse by parallelogram method, and the side of the parallelogram is 100 mm by 70 mm and the included angle is 75 degree. So first of all, draw the two sides of the parallelogram, AB and CD, and the included angle is 75 degree, and construct and the angle is 75 degree, and divide the left side into 4 equal parts, and the left side of AB into equal parts, and join D1, D2, D3 and join C1 and extend it, join C2 and extend it, join C3 and extend it, and mark the points. Then you can transfer the points to the right side and the bottom side, and you will get the ellipse. So this method is called ellipse by parallelogram method. And next is the Aqua Circuits method, and given the major axis is 100 mm and the minor axis is 70 mm. So draw the major axis AB 100 mm and the minor axis CD as 70 mm, and the intersecting center point is O, and mark two focuses F1 and F2 by taking AO as radius and center C. Cut the major axis on both the sides. You will get focus F1 and F2, and divide F1O into 4 number of equal parts, and draw arcs taking radius A1. Take radius A1 and center F1, draw an arc. Then take radius B1 and center F2, draw another arc. So this is the point. The second point is take radius A2 and center F1, draw an arc, and take radius B2 and center F2, cut an arc. Similarly, the third point, you can mark the third point and fourth point. So, and mark all these points, and P1, P2, P3, P4. Draw 1/4 of the ellipse and convert the P1, P2, P3 points to the right side and the bottom portion, and join all the points. You will get an ellipse. So this is the ellipse by using Aqua Circuits method. So as per the definition of the ellipse, it is the locus of a point P moving in a plane such that the sum of its distances from two fixed points F1 and F2 remains constant, and it is equal to the length of the major axis AB. Note that A1 plus B1 is equal to A2 plus B2, which is equal to AB. So this condition is to be satisfied. So another is the rhombus method. So draw a rhombus, the 100 mm by 70 mm long, and the diagonals and inscribe an ellipse in it. So draw the rhombus and mark the points A, B, C, D. Join the diagonal lines as shown in the figure, and join 1A, 2D, 2C and B1. The 3 is a point which is the intersecting point of 1A and 2D. 4 is a point which is an intersecting point of 2Z and 1B. So you will get the top portion and bottom portion of the ellipse, similarly the left portion and the right portion of the ellipse. So this is the ellipse by using rhombus method. So next is the directrix focus method. So question is, point F is 50 mm from a line AB. A point P is moving in a plane such that the ratio of its distances from F and line AB remains constant and it is equal to 2 by 3. Draw the locus of point P. Eccentricity is 2 by 3. So from the question, the eccentricity is 2 by 3, which means if the eccentricity is less than 1, then the curve will be ellipse. So draw a vertical line AB. So draw the vertical line AB, and so this line is called a directrix. Then draw another line perpendicular to the directrix and mark focus F on it. And we know that the distance from the directrix to focus is 50 mm, and divide the 50 mm into 5 equal divisions and mark the vertex V, such that VF is 2 division and V2 directrix is 3 division, such that the condition is satisfied. VF is 2 and V2 directrix is 3. And so mark points 1, 2, 3 on the right side of the focus and take so from the focus you can see this distance is 30 mm, and from that point that distance is 45 mm. So draw a line to the right side of the focus such that form more points giving some ratio such that 30 by 45, 40 by 60, 50 by 75, etc. And taking 45, 60, 75 millimeter distances from the line AB, draw 3 vertical lines to the right side of it. So now with 30, 40 and 50 millimeter distances in compass, cut these lines above and below the major axis with F as center, and join these points through vertex V, which is a smooth curve. This is the ellipse. Next is the parabola by rectangular method. So a ball thrown in air attains 100 meter height and covers a horizontal distance of 150 meter on ground. Draw the path of the ball. This is projectile motion. So draw the rectangle and divide the left side into 6 equal parts and mark it as shown in the figure, and divide the bottom portion into similarly again 6 equal divisions, and join the top center point and left 1, 2, 3, 4, 5, 6 and draw perpendicular lines through the bottom 1, 2, 3 to the corresponding points, and draw a smooth curve and mark the intersecting points like this, and draw a smooth curve passing through all these points. So this is the parabola. So this is the path of the ball. Next is the method of triangles. Question is, draw an isosceles triangle of 100 mm long base and 110 mm long altitude. Inscribe a parabola in it by the method of tangents. So construct a triangle as per the given dimensions and divide divide AZ and BZ into same number of equal parts and number it one side it in the ascending order and the other side in the descending order as shown in the figure, and join 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9 9 10 10 11 11 12 12 13 13 finally 14 14. So draw a smooth curve past which is the points are the tangents to the line. So this is the required parabola. So draw a curve through the tangents of the line. So next is the parabola directrix focus method. So this is the directrix, AB is the directrix, and draw a perpendicular line which is directrix perpendicular to the directrix and mark the focus. Focus is at a distance of 50 millimeter, and the center point of OF is the vertex, which means the eccentricity value is equal to 1, which means VF and VO are equal. So mark the number of points 1 2 3 4 to the right side of the vertex, and with the center F and radius O1, cut the first line and take O2, and with the center F cut the second line. Similarly mark all other points and draw a smooth curve passing through all these points. We will get the parabola. So this is the hyperbola. So point P is at a distance of 40 millimeter from the horizontal and vertical axis. So first of all mark the point. That point is at a distance of 40 millimeter and 30 millimeter. So this is the point P. Divide the line into 4 equal divisions are marked. It is 1 2 3. Similarly the horizontal line into equal divisions and from O join the line O1 O2 and O3. Similarly O1 O2, and it will touch the horizontal line at 1 2 3 etc. And 1 2 etc. and draw a perpendicular line through 1 2 3 and draw parallel lines through 1 2 3. It will meet the lines. So these are the points. Similarly in the left side draw perpendicular line through 1 2 and parallel lines through 1 2. It will touch. So these are the points. So draw a curve passing through all these points. So this is the hyperbola. So this is the PV diagram of a hyperbola. So the P into V is a constant, which means the x-axis is volume and the y-axis is pressure, and mark the divisions 1 2 3 to 10 similarly in the x and y axis, and the condition is P into V is constant, and take different values. So first of all P is 10 which and V is 1, which is P into V is equal to 10. So this condition should be satisfied. Then the second case is P is 5 and V is 2. Again 5 into 2, this is 10, which is a constant. The third case is 4 into 2.5, which is 10. Again the fourth case is pressure is 2.5, the volume is 4, and the fifth case is pressure is 2 and volume is 5, and the last case is pressure is 1 and volume is 10, which is 10. And according to that mark all those points and mark the points and draw a smooth curve passing through all these points. So this is the hyperbola. This is the hyperbola. So next is the hyperbola by directrix focus method. So draw a given line AB and mark the focus F, and mark the vertex V such that the condition should be satisfied, and from focus to the distance is 45 millimeter, and from the directrix it is 30 millimeter. So the ratio should be satisfied. So mark different points as per the same ratio such as that 30 by 45, 40 by 60, 50 by 75, etc. And taking 45, 60 and 75 distances from line AB, draw 3 vertical lines to the right side of it. Now with 30, 40 and 50 millimeter distances in compass, cut these lines above and below with F as center. So join these points through a V to a smooth curve, and the curve is the hyperbola. Next is how to draw a tangent and normal to the curve from a given point. So this is the point Q, and join Q with the focus F1 and F2 and draw angular bisector of F1, Q, F2. You will get normal, and draw a perpendicular to the normal. You will get the tangent. So this is the tangent and this is the normal. Next is again another point Q, and join Q and F, and from F draw a line which is angle is 90 degree. It will meet the directrix, and join directrix and that point and Q, that will be the tangent, and draw a perpendicular line through that point Q. It will be the normal. So TQT is the tangent and NQN will be the normal. Next is the parabola. So this is the point Q. So join Q and F, and angle F is 90 degree. It will meet the directrix, and join that point and Q, that will be the tangent, and draw a line perpendicular to that. It will be the normal. So TQT is the tangent and NQN is the normal. And in the case of hyperbola, again this is the point Q. Join Q and F, and angle F is 90 degree. It will meet the directrix, and join that point and Q, that will be the tangent, and draw a perpendicular line through that. That will be the normal. So NQN is the normal and TQT is the tangent. So these all are the cases of conic sections. That's all. Thank you.